Hey guys, this video is going to teach you about the remainder theorem. So the remainder theorem is related to the relationship between the factors and the roots. So by now you should understand the relationship that if -2 is a root, then x plus 2 is a factor. And the reason that they have that relationship is because if you plug -2 in, this factor will equal 0. Same thing, if this is a +3 as a root, then x minus 3 will be a factor because 3 minus 3 is 0. So those are factors, which means the remainder is 0. It goes in evenly. But if you were, for example, to take +1, there would be a different number. You would not get 0. So if I were to plug 1 into this, that answer that I would get is called a remainder. So basically, we're just going to be using that concept. So in the first problem, find the remainder when this polynomial is divided by x plus 3. So I'm going to start with the piece that looks like a factor. And if it is a factor, then it should equal 0. So I'm going to solve this. I'm just going to subtract 3. So x is equal to -3. So I'm going to take that and I'm going to plug it into my function. Anywhere I see an x, I'm just going to plug in -3 and I'm going to work it out. And the answer that I get is called a remainder. So -3 squared minus 2 times -3 plus 10. You can just plug this all into a calculator or you can work it out step by step. Order of operations. That would be 9 plus 6 plus 10. So the remainder is 25, which means x plus 3 is not a factor of this polynomial because we have a remainder. That means it did not go in evenly. All right, so same thing. Question number 2, is x minus 2 a factor of that polynomial? So I'm going to take the part that looks like a factor. If it is a factor, it will equal 0. So I'm just going to add 2 to both sides and get x equals 2. And I'm just going to plug 2 in for all of my x's. All right, and again, you should know by now that these videos are your notes. So pause, rewatch, copy these examples into a notebook so that we can talk about them when we meet live. So exponents first. And that all comes out to equal 8. So since we got a remainder, this is no. X minus 2 is not a factor of that polynomial. It would be a factor if we got 0, because that would mean it went in evenly with no remainder. But if you get any number besides 0, then what you were trying to divide by is not a factor. All right, so we're going to extend that concept to actually like finding missing components of a polynomial. So for question number 3, what value of k will make x minus 2 a factor? So again, if it is a factor, then this factor has to equal 0. So it would have a root of +2. So I'm going to plug +2 into my polynomial. All right, now this is an equation. I have a missing variable, which means I have to set this equal to something. So somewhere in the problem, they gave me a clue as to what this polynomial is supposed to equal when I plug 2 in for all my x's. And that word is factor. In order for x minus 2 to be a factor, when I plug in +2, I need to get 0. So now I can solve this equation and figure out what k is. So I am going to take this plus my 8. I'm going to leave that alone because I have a lot to simplify before I can solve for k. So I'm just going to simplify everything that I underlined. And again, you could just plug this into the calculator all at once, but I don't have a calculator, so. All right, so when I simplified all of those constants, I got 8. So my new simplified equation, I'm just going to swap those because we don't really write equations with the variable first. We put the coefficient first. So 2k plus 8 equals 0. This is now just a two-step equation where I have to solve for k. So I'm going to minus 8 on both sides. 0 take away 8 would be negative 8, and I'm going to divide by 2. So k has to equal negative 4. All right, last example. The remainder when that polynomial is divided by x plus 2 is 8. Find k. So again, I'm starting with the factor piece. In order for this to equal 0, x should be negative 2. So I'm going to plug negative 2 in for all of my x's. All right, just plug negative 2 in for all of my x's. And again, this has to equal something. So they told you in the problem what it is supposed to equal. It said that it is 8. So that means when I plug negative 2 in for x, I'm supposed to get 8 as my answer. Oops, and I still have the last problem on the brain. That last thing is supposed to be k, because that's the piece of the polynomial that I'm missing. So sorry guys, I just had the last question on my brain. The last question ended in plus 8, so I just wrote plus 8 instead of plus k. Alright, so again, I'm going to work this out. So please excuse my dear Aunt Sally, exponents first, that would be 16, but the negative, making it negative 16. Alright, and I am going to cheat and pull out my calculator just because I don't feel like doing all this mental math right now. And I'm running out of paper. Alright, so that all combines to negative 52. So my equation, negative 52 plus k is equal to 8. So I'm just going to add 52 to both sides to get k by itself. So k has to equal 60. Alright y'all, again, rewatch this video if you need to. Pause it so you can copy all of these examples down. Your classwork is a Google slide that has a few more examples worked out for you and then a few for you to try on your own.